So okay. So today we are going to learn about that triangular element. So first we will see one problem. So this is the one of the problem that we are going to solve by using. This is a triangular element having 6 nodes. So this is node 1. Sorry. Let me use that one. Let me use my chaser. Yeah. This is node 1 and yes, no, correct. This is node 1, node 2, sorry, node 1, node 2, node 3, then node 4, node 5, node 6. This is having total 6 node. Okay, having total 6 node, and this is triangular element. So this is our triangular element, and what they are saying that find the shape function for all 6 degrees of freedom. So we are having total. So let me move this one here. So we are having total 6 degree of freedom, and we need to find an shape function. So how many total? So we are having total 6 degrees of freedom. So we will have 6 shape function. N1, N2, N3, N4, N5, N6. Okay. So total we have to find 6 shape function. Okay, and given that this is node 1 having coordinate origin 0, 0. So node 1 0, 0, node 2 2, 0, node 3 0, 4, node 4 1, 2, node 5 0, 2, node 6 1, 0. So these are the all 6 coordinate of given nodes. So total we are having 6 nodes, and this is triangular element. Before going to solve this problem, I will tell you how to solve this problem for this different triangular element. This is also called like CST, constant strain triangle. Okay, this will get after discussing with CST. After having some discussion about CST. So first we will learn about what is CST. Okay, what I am calling CST. Okay, so let me take my pen. So like if we are solving any problem, any FEM problem, what we are doing, first we are dividing our element. First we are dividing our element in different number of small element. So like for example, this is our this is our one of the member, and I want to find like displacement or force, anything, or strain. I want to find somewhere. I don't know which location, so I'm saying this location. I want to find this parameter like displacement, force, and strain. So what we are going to do first? What we will do first? We will divide this full member in small number of element. For example, and these are called like meshing. So first we have to do meshing. Then what we are going to do first, we will, for example, first this flame, I want to get some displacement this nib point. What I will do first, I will divide this, like for first we are going to break this one in small element. Then after we are going to sum up to make again the same element. So what we are doing, we will cut this element in different small element. Okay, small element. Then after we are going to assemble to get our actual element. So for example, this is one of our 2D element, and this is one of the small element. So it is having 4 node, node 1, 2, 3, 4. Okay. This is having total 4 nodes. So what we will say, this is our element, and this is our, okay. So let me make a little bit sound. Hello, can you hear me? Srikant, can you hear me? You can just say yes, no. Srikant. You can type in chat window. Can you hear me? Srikant, can you hear me? Hello, Srikant, can you hear me? You can reply, please. I think. Okay. If you hear me, just let me know. So, okay, what I've been saying, so from where I started. So this I will just explain you once again. So this is one of the trigonal element, and this is the trigonal element. Then we need to find for this is having 6 node, node 1, 2, 3, 4, 5, 6. It is having total 6 node, and we need to find shape function for this triangular element. So we need to find all 6 shape function because it is having node 6. So n1, n2, n3, n4, n5, n6. These are our 6 shape function, and that we have to find. Okay, so what I'm saying, so any 2D element we have to divide into small element. Then we are going to assemble to get the full element. So okay, so this is our one of the element. So this is our element. It is having total 4 node, node 1, 2, 3, 4. This is moving in 2D plane, so it is having only x and y degree of freedom. So this is like u1, u2, u1, b1, and node u2, b2. So this is horizontal displacement, horizontal. This is vertical. Okay. So like for node 1, u1, v1, node 2, u2, b2, node 3, u3, v3, node 4, u4, b4. So this is our one element. So like if I will say, if I want to write this nodes element in matrix form, or I will say in vector form. So how we can write? So like this is d. D means displacement, and this means vector. So d equal to u1 v1 for this is for node 1. This is for node 2, node 3, node 4. Okay. So this is our displacement in vector form. Displacement of what? Displacement for what? For this element. Our displacement for this element, this is d. Okay, u1, v1, u2, b2, u3, v3, u4, b4. So we are having total 4 node. So we are having total 8 displacement because each node having 2 displacement. Okay, so how we are writing, like in general. So this is about U. U means horizontal displacement. I will write here. U means horizontal displacement, and B means this is vertical. This is our vertical displacement. Okay, so this is N1 U1, N2 U2, N3 U3, N4 U4, because we are having 4 nodes. Okay, so how many shape function we will have? 4 shape function. N1, N2, N3 and N4. So total we will have 4 shape function. Okay, yes. Now, so this is for horizontal displacement, and this is similarly. So how we are writing, like U x comma y equal to summation Ni and Uy, I equal to 1 to 4. Okay, similarly Bx comma y equal to summation I equal to 1 to 4 Ni Bi. So when we will expand what we will get, this Ux equal to N1 U1, N2 U2, N3 U3, N4 U4. Similarly, B equal to B1, N1 B1, N2 B2, N3 B3. Okay, and let me change the other plane. Okay, this one. Yeah. Then N3 B3 and N4 B4. Okay, so this is our displacement in terms of that shape function. So similarly, what we can do, we can write this one in terms of matrix. So in terms of matrix. Okay, so hello, can you hear me, Nandlal? You can reply yes, no.
Hello, yes sir, tell me.
Yeah, so thank you, you can hear me. So I missed some of the class, but we will recover. I will send one mail and you will get that message for extra classes.
Okay, thank you.
Okay, so like I will explain what we are doing. I'm just starting that CST, constant strength triangular element. So I will just give you a brief intro what today we are going to do. So this is one of the triangular element, and we need to find displacement. Sorry, we need to find shape function for this element. So this is having 6 nodes, like node 1, node 2, node 3, node 4, node 5, node 6. So this will have total 6 shape functions, n1, n2, n3 up to n6, and we need to find that value, like expression of this 6 shape function. So like these are the coordinate for node 1 origin, node 2 2, 0, 3, node 3, node 4 up to node 6. Okay, so this is having 6 nodes, and simple form other form what we can see, like other element will have only 3 nodes, like this: node 1, node 2, node 3. So this is also one of the triangular element, and in this form also it can be node 1, node 2, node 3. But in this problem we are having total 6 nodes. Okay, so initially I will give you little Initially I will give you little intro about how to calculate that shape function and strain for this triangular element. Then we will come back to this problem how we can solve. Okay. So I started from here. So like we are having any element. This is 2D element. So what we are doing, we are breaking this element in number of small element. So like these are different number of small element. So in this domain, we are having one of the element this is our one element. I taken from here to there, and this is having total 4 node, like node 1, node 2, node 3, node 4. And each node having 2 degree of freedom, like u1 in x direction, b1 in y direction. So because we are having, this is our 2D elements, it will move in x and y direction. So u1, b1 for node 1, similarly for node 2, u2, b2, for node 3, u3, b3, and similarly for node 4, u4, b4. So this is our like one element. So I write here element E. E means element. Now, so what we can like, what is this? This is displacement of this element in terms of vector. So normally what we are doing in FEM, we are writing most of the thing in vector only, vector form, because it is easy to handle and we can understand easily. So this is D equal to U1, B1 for displacement node 1, U2, B2 for displacement node 3, similarly for node 3, sorry, this is for node 2, node 3 and node 4. Okay, U1 means horizontal, B1 means vertical. So this is having 4 node, so it will have total 4 shape function n1, n2, n3, n4 till now. Okay, so how we are getting total like displacement? So like in horizontal direction, U equal to summation of I equal to 1 to 4 ni ui. What is n? N is the shape function. Okay. Similarly, in vertical direction, ni bi, b is the nodal displacement, and n is the shape function. So how we can write? So like in horizontal direction, n1 u1, n2 u2, n3 u3, n4 u4. This is in horizontal direction. Okay, for if this is moving like this is in for horizontal, this is for vertical. Similarly, in vertical direction, n1 u1, n2 b2, n3 b3, n4 b4. This is for vertical direction. As of now. Now, what we can do, what I want to write, so this is like long expression. So, and look little like a big expression. What I will do, what we are doing, I will write this expression in matrix form. So this expression, same expression in matrix form. So like U equal to, U is the total displacement, and this is the like, this means vector. Like I'm writing force, this means force vector. Okay. So this is vector. So U equal to ux bx. This is the displacement of that element. Then n1 0, n2. How I will how we will get from this matrix to here. So I see like this is u1 n1 plus n2 u2, because we don't have b1, so this will become 0. Then n3 u3 n4 u4. So directly you will get this expression, correct? Similarly, in case of vertical displacement, so like 0 we don't have u, but n1 b1 yes, then 0 u2 we don't want, then n2 b2 yes, similarly n3 b3 n4 b4. So this expression we can write in this way. Yes. Okay. So why we are writing? Because we are just for example, we are writing code in FEM. So what we are doing, we are giving all the expression in matrix form. So they will not understand what we are writing, but in this form they will understand easily what we are trying to give as input. Okay. It is correct till now? Are you getting?
Yes, sir. Yes, sir.
Okay. So similarly, this expression in short form, how we can write? See, this is displacement, and for this whole expression, I will say this is our shape function. Okay, and for this expression, I will say this is our displacement function. So in short form, how we can write? So this like U displacement and this is our nodal displacement. Like this is our nodal displacement. Nodal displacement. Okay. So what we did as of now, we started from this element. This is our four node element, 2D 4 node element. We got this expression in terms of shape function. Then we reduced to this matrix. Then again we came here in this small expression. So if someone will say you are having this expression, it means that this is nodal displacement, this is overall displacement of element, this is our shape function. Okay, till now. Now, what we are normally doing, for example, we are having this one bar and I want to find strain. So what we are doing, like strain equal to delta L by L. This is for like for simple this like beam or bar condition. But we are having this 2D element. So we have to take that partial differentiation. Okay. So now how we will find display that strain? Strain for any element T. But we are having this element. This is having node 1, 2, 3, 4. Okay. 1, 2, 3, 4. We are having total 4 shape function N1, N2, N3, and N4. Total we are having 4 shape function. So now, see, we are having displacement. This is our displacement. So I will write here again like U equal to Ux comma y equal to N1 U1 plus N2 U2 plus N3 U3 N4 U4. So this is also like function of x comma y, all displacement function of x comma y. So what will be strain? Strain equal to in x direction. Strain in x direction. In x direction, we have to take like partial differentiation. So like del u by del x. So what will happen? So like this, like sorry, one thing I forgot here. So look, this is our constant. This our shape function is the function of x comma y. This is nodal displacement. How it can be variable. Okay. So now what will be by strain? So this is our constant. This one we are not going to differentiate. This is constant. So by displacement will be, so the strain will be like del n1 by del x u1 plus del n2 by del x u2 plus del n3 by del x u3 plus similarly u4. So this will be our strain in xy direction. Okay. Similarly, we are having function this vertical displacement. Similarly, this we are going to differentiate. We will get strain in y direction, and this is our shear strain. Okay, this will be our shear strain. I think till now, am I correct or do we? I think this is basic only. No need to.
Yes, these are basics.
So I will just go a little fast. So again, like these are our different, these are our metric, these are our the strain in equation form. So again, what we can do, we are writing in matrix form. So these above equation we can write in matrix form. How we can write? So like strain vector form equal to strain in x direction, strain in y direction, strain like this is shear strain. So like this we can write. So this will number strain. Okay. And after writing in this vector form, what you will get this big expression after in converted into matrix form. So like this is our n1 by del like n1 by del x, n2 by del x, n3 by del x, n4 by del x. Similarly, by like vertical strain, and this is our shear strain, and these are our nodal displacement. So I will write here these are our nodal displacement. Okay, so in short form, what we can write, this is our final strain vector. Okay, so okay, so this is our nodal displacement d, this is our strain, and what this is our like someone calling like shear strain vector, some calling only b. So this is our b vector, this is our b matrix, this big one, whole matrix, this big one will be b matrix. So like till now, if I will write in short form, like for any element, this is our any element, node 1, node 2, node 3. What will be displacement? So u equal to n d. Okay, then what will be strain? So strain equal to b n d. But n will be our this matrix, n1 0, this. Then what will be b? B will be our this matrix, and d will be our this matrix. So like when we are writing any code, normally what we are doing, we are saving one variable, this one like as a b matrix, and we will use number of time in different, like if we are writing any code, somewhere we need to find strain or stress anything, then directly we will call. We don't have to write this big expression again and again. So like this simple form, like code will understand easily. Oh, this is matrix, I have to do something. Okay, for this. Okay, now we can move forward. So like summary, what we can say in summary, displacement, strain, what will be stress? Stress will be our sigma equal to d bd. What is d? Like d matrix, I didn't find here. Later I will explain. Okay, so this will be our elemental stiffness matrix, and this will be our elemental force, like nodal load vector. Okay, so till like as of now we seen that element with 4 node. Okay, and but I was telling about CST, constant strain triangle. So what we have to do, we need to get back to only 3 node. So this is called CST. Simplified 2D element. This is having only 3 node. Node 1, 2, 3. Node 1, 2, 3. Similarly, like node 1 having displacement u1, b1, u2, b2, u3, b3. Okay, then x1, x2, x1. So like x1, x2 by 2, x3 by 3. These are nodal coordinate. Nodal coordinate, and b1, sorry, u1, b1, u2, b2, u3, b3. These are nodal displacement. So for example, this will move in x and y also. So to find this nodal displacement, we are exact displacement, we are going to use this nodal displacement. Okay, so this element having 3 node. So 3 node, and each node having 2 degrees of freedom. So total will be, our stiffness size will be 6 by 6, 2 into 3. So 2 into 3. This will be our total stiffness size of matrix, like stiffness, mass, damping, all these things will be 6 by 6. So 3 node per element, and it is having 2 node per node. So total will be 6 degree of freedom per element. So like for example, we are having any domain. This is our random domain, and we are dividing in a triangular form, different triangle, like this. So like different triangle, this one, this one. So for all element, stiffness size will be 6 by 6. And after assembling, we will get, I don't know how many number of element, but for one element, we will have 6 by 6 element size. Okay. Again, same. How we can write that displacement? How we can write displacement will be our Q equal to summation I equal to 1 to 3, because we are having 3 node, then Ni Ui. So this will be our N1 U1, N2 U2, N3 U3 in X direction. In Y direction will be N1 V1, N2 V2, N3 V3. So this is our displacement, and this one we can write in matrix form also. So this will be the U and B, U and V. This is our shape function matrix, and this is our nodal displacement. This is our nodal displacement. Okay. Is so this is having size 6 by 1. This will be 2 by 6. Again, so what will be our size of this? So this will be our 2 by 1. Displacement will be 2 by 1. Yeah, it will be 2 by 1 because we are having X and Y only. 2 displacement. This is our N matrix. Correct? I am going okay now. Any suggestion, any comment?
Okay, sir, fine.
Okay, who is other joining? Okay. So like why we are doing all these things? Because like for example, this is my mobile, and I'm going to put some load here in middle of this mobile, and I need to find displacement at this edge. So what we can do, we will break this mobile in number of element. So every time we cannot have a square element or beam element. Maybe sometime we will have a random element, and that we have to divide in different, some triangle, some square, some cell, some solid element also. That's why these are different type of element, like for example, this is one problem. So for this element or this member, I can easily divide this one in different square element, like I will say like 2D element, this one like this, different like rectangle, number of rectangle. But in some case, like for example, we are having this and like this. So here we cannot make our rectangle at this location. At this location, we cannot make rectangle. So here we have to use only triangular element. That's why we are adding different like rectangle, square, triangle, different type of element. Yeah, I think this is clear. I think this is clear for you. Yeah. So again, like so I said this is here we cannot make rectangle. Okay, so I'm making here triangle element. But for this element also I need to find displacement, force, strain. So how we are going to find? So like we are having one procedure to find displacement or strain or force. Like for I want to find strain. So first I will find displacement. What is the displacement change between two position. Okay, before going to find that displacement, what I will find shape function. So like shape function, then displacement, then strain, then stress, then force, everything we can find. This is like one procedure we have to go. So, okay. So now, first what we are going to do, we are going to find this shape function. Okay, then we will go to displacement, then strain, then stress, then force. So first we are going to learn how to find shape function for any triangle element. Okay, so this is our 3-node element. So this is having node 1, node 2, node 3. So this is having 3-node element. And as initially I also told you, these are the U1, B1 nodal displacement, U2, B2, and U3, B3. So for this, any triangle element, these are the predefined like mathematical equation. We can derive also, but we don't want to go in depth because we have to assume some like base function, then we have to differentiate. So many things we have to do. So we are not going to do that one. But we are saying this is like predefined shape function for this triangle element. So we are having 3 nodes. So total we will have 3 shape functions. So this is like n1, n2, n3. These are our shape function.
One doubt, N1,
Yes.
how we have written value of N1 as A1 plus B1x plus C1y by 2a. Can you explain that one, sir?
So like that's why I'm telling. This is like very long the derivation.
Okay, sir. I will go through.
That's what I'm saying. So like first we have to assume, like how we are finding. Okay, I will give you just one clue. How we are finding that. Wait, how to get this page? I need some space. Okay, here. So like for example, like we are having one element. This is our bar element, or I will say this is our beam element. And we are saying this is having displacement U1, B1, and theta1. Or I will say it is having only 2 displacement. This is not plane, this is only having only 2 displacement. So like B1 and theta1, B2 and theta2. So how we are finding shape function? First we are saying this is having U equal to A node plus A1x plus A2x square plus A3 x cube. We are assuming some some displacement, random displacement. We are assuming this one. Like shape of this function will follow this displacement. Then we are putting some boundary condition. For example, boundary condition like I am saying this is fixed. So x equal to 0, u will be 0. At x equal to 0, or at x equal to 0, that displacement del like du by dx will be 0. So this is our 2 boundary condition. Okay. Now what we are going to do, we are going to use that beta residual function. Beta. But then we are going to find strain something, and then we are going to integrate like w1 ux dx equal to 0. Did you remember these things? Yes.
See, I have not revised,
So like this is the one procedure. So then after solving, you will get some value that is called like n1 and n2. You will get these 2 functions.
Okay, sir. I will go through.
So this is so according to this like course requirement, we don't have to go through that long derivation. We have to remember like some like critical important things, like what is the shape function for triangular element, what is the shape function for beam element. So I think you got okay. So this is our shape function. Similarly, we can derive for this triangle, but it will be very long expression. So normally we are not deriving. We are saying just giving that this is shape function for triangle element. Derivation we also can do, but this is not required at all. Okay, so this is our shape function for this triangle element. And what is A? Is the area of triangle. I think area we can find like in determinant form like 1 x1 by 1 x2 by 2 x3 by 3. After getting this determinant, we will get area of the triangle element. And what is a1 b1? So a1 equal to x2 by 3 minus x2 minus x3 by 2. This is like I will say difference like x2, like if I'm writing
You said, I think minus or cofactor, something will be there.
like you can say. So like see, this is x2 and this is by 3, then x3, then by 2. So like this one and multiply by this here minus. Similarly, this a1, a2, a3, then what is b1? b1 means difference between two coordinates. So like by 2 by 3 and c1 x coordinate. So similarly, A1, B1, A2, A1, A2, A3, B1, B2, B3, C1, C2, C3. These are the predefined coefficient. So just we have to put here these value and we will get the shape function N1, N2, N3. Yes, done. I think we know that what is the property for at like I will say I equal to 1. At I equal to 1 is shape function n1 will be 1 and other node it will be 0. These are the property of shape function n1, n2, n3. This one more like for any summation of shape function every time will be 1 and in x direction ni xi it will be x, in y direction it will be y. Okay, these are some property. Okay, so like this is also other way to find that shape function n1, n2, n3. How we can find? So I will explain in this way. So like this is our one element, any element, and this is having like node 1, 2, 3. Okay, so this is node 1, 2, 3, and this is our like what we are calling centroid. Yeah, this is like centroid. So I will say this is x comma y. It is having point P. So for example, I want to find that shape function for this node 1. So what I will do, I will connect, I will connect first this one like this. So opposite to this node 1, I will say area n1 a1. Opposite to node 2, I will say area a2. Opposite to node 3, I will say area a3. Okay, so like what is the area of a1? Like area of this triangle, this one. Okay, then what is a2? So area of this
P
one.
is the point of P point is known as CG.
Yes. Centroid. What we are calling CC or centroid?
Centroid.
Centroid. And what the area of A3? This will be our area of this triangle will be A3. So if you know all the like coordinate and centroid, simply by putting like n1 will be our a1 by a. What is a is the total area for this triangle. Total area. Okay, so this will be our n1 equal to a1 by a, n2 equal to a2 by a, n3 equal to a3 by a. See, like this point can be anywhere. No need to go in. I think this is not required to be at center because we are assuming p as x comma y. Yes.
Maybe anywhere.
Hmm?
Maybe anywhere.
It can be anywhere, just that we are assuming. So normally we are saying centroid because it will be easy to find this area, right? So then what will be strain? Strain will be similarly equal to del u by del x ex, then ey equal to del u by del y, del b by del y, then ex by equal to del u plus del y plus del b by del u plus del x del b by del b by del y. So this will be our strain. Then what will be B matrix? This is our this long B matrix. No need to remember. If you are solving any problem, they will provide you these matrix. If you are able to recall, that is very good only. Simply like see, derivation with x, then 0. Derivation with x and like n1, n2, n3. I will write in one way only, like this way. Like n1 derivation, then 0, n2 derivation 0, n3 derivation, then 0 again. Similarly, start from 0, 0, n2 derivation, then 0, sorry, n1 derivation 0, then n2 derivation, then 0, then n3 derivation. Then here again, then del n1 by del x, or I will say like derivative only. So
but here derivative with respect to x and with respect to y, how will understand, sir, by writing this way?
see, like what we can do. So how we will remember? Then we have to remember this expression. How we can remember? I will tell you. N1 by del 1 by del x. Del by del n by del y. So you can say like first we will did with x, then by, then two terms of by, like this is for by x by x by x. Like this you have to remember. X y, then by x by x by x. First for n1 to n1, then again 2 for n2, then last 3 for n3. Some trick we have to make.
Okay, you are right.
Correct, na? X by x by x by x. So, or you can remember like, see, this is our horizontal strain like Ex. This is our horizontal vertical strain Ex, Ey. And these are our that shear strain like XY. So, what you can say, you can write by x just to remember. I will say in this, I will write in simple form. So, to remember this one, so this will be by x, then by x by x by x, not xy, because first initially we already wrote x and y, so we have to write by x. Like that we can make one trick.
Okay, sir.
Then this will be stress. So what we can do? Strain elemental. I will this one I will let you later. Then we will come back to our one problem that initially I told you. So this problem now we are going to solve. Okay. So this is having 6 nodes, but as of now, till now we study only for 3 nodes. But this is having 6 nodes. Okay, no problem. This is having 6 nodes, like 1, 2, 3, 4, 5, 6. It will have 6 node shape function, and we need to find all 6 shape function. Okay, fine. So I wrote here these are our coordinate for all nodes. Fine. So like for node 1, I will say x1 by 1, node 2, x2 by 3, by x2 by 2. Not here I wrote little wrong. So this is our x2 by 2. So x1 by 1, x2 by 2, x3 by 3, then for x4 by 4, these are all the nodes. All the coordinate for all nodes. Okay. So these are the one I written here. Then we have to find A1, A2, A1, A2, A3. These are area A1, A2, A3. So what is the area A1? Area opposite to node 1. So area opposite to node 1. This will be your A1. What is A2? Area opposite to node 2. So area opposite to node 2. This will be your area 2. This P point can be anywhere x comma y coordinate. This is not anywhere it can be. Then A3 opposite to node 3. So this will be your, this is node 3, this is our opposite to node 3. So we have to find A1, A2, A3. Then what will be your sec function? Sec function directly will be n1 equal to, yes, okay, I will let you know later. Okay, so now I'm going to find area A1. How we can find area A1? So how we can find area A1? So area A1 equal to, so this is our area A1. So this will be our area A1. So like we are having two coordinates, 1, 2, for x2 by 3, x3 by 3, and this will be x comma y. Okay. It is correct.
Okay, sir, we will find out from determinant method.
This is, I think I wrote wrong here. This is wrong, right? This is correct only. Let me remove this one. Because if we are finding area, this is actually, this is full area, this is total area, this is not A1. This is total area. So this is our, not this is our total area. Sorry, I wrote here. This is our total area. This is our total area. Total area, yes. So now we are going to find that area A1. So well, area A1, 1 by 2, x by 1. Sorry, x by, these are the coordinate of this any point P. Then x2, x3 for this one, by 2 by 3 for like x2 or by 2 for this node, x3 by 3 for this node 3, and this is 1, 1, 1. So after finding this then after putting of value x2 by 3 by 2 by 3, so x2 equal to 2, x3 equal to 0. I already given here this one. So x2 2, then x3 0, and by 2 0, by 3 4. So I kept here. So this is our after putting value. So what you will get, A1 equal to x minus 4x minus 2y plus 8. This is our 2A1. So this is our 2A1, value of 2A1. Okay, fine. This is our 2A1. Similarly, A2, so area opposite to node 2. So area opposite to node, this is our node 2. Are you getting now what I'm, right?
Yes, sir, I am getting, sir.
So like this is node 2, area opposite to node 2, this will be our area opposite to node 2. This point can be anywhere at P. So x by, this is for point P, and x3 by 3 for node 3, x1 by 1 for node 1. Okay. After putting value for x node 1 and node 2 coordinate, what we will get? We will get 2A2 equal to 4x. So we all also got area of A2, 2A2 equal to 4x, and 2A1 equal to minus 4x minus 2y plus 8. So we got two area. Now this is for area 3. This is for node 3. This is for node 3 because area opposite to node 3, that will be area A3. Similarly, after putting value x by, this is for any node, any point P inside that domain. Then x1 for node 1. Then this is for node 2. And after putting value, what we will get? We will get 2A3 equal to 2y. So till now what we got? Area for node 1, area for node 2, area for node 3. Yes. Yes, correct. So, and so this node I taken somewhere in the domain. It can be, but it should be inside. It should not be outside that our domain. For example, I'm saying this node P is at node 1. It means that this P is shifted to node 1 means it is having coordinate equal to origin. So I will say if P is at node 1, then P will have uh, coordinate value 0, 0. Okay. So what will happen? This will become full triangle. It means the area of this full triangle will be area of A1. So if I will put x comma y equal to 0 here, then we will get 2A1 equal to 8, A1 equal to 4. And we also seen here the total area of this triangle equal to 4. So this point can be anywhere. If this P point I shifted to this node 2, then it will the coordinate on point P will become x2 by 3. And if I will put coordinate of coordinate of point P here, then the area of A2 will become area of total triangle. So after getting these area, we can verify also this is correct or wrong.
Means once we move the point P at nodal points, then area of the triangle will be the full area, no?
Yes, correct. Like this is a one way to verification of these our that whatever area we got. So one way to that correct we are doing wrong or right.
Okay, sir. Okay.
So now I want to find that shape function for all 6 node. Shape function for all 6 node. So I think can I know like in class sir covered that CST constant strength triangle element. Did he covered or he is going to cover?
Taught in the previous classes, sir, but I am not fully aware.
Okay. So like see again these are some formula that is used for especially for 6 node element. Like we are having 6 node na. So these are we are also calling like for example we are having 3 node, then this formula will be different. Then 6 node, then formula will be different. So just you have to patience because these are some formula I'm not going to drive. Okay, so I will tell you. Then what is L1?
There in textbook or not, sir?
Sorry,
Is derivation will be there in textbook?
yes, you can find in textbook.
Okay, sir. Okay, fine. I will search.
So now what is L1, L2, L3? Area based on coordinate system denoted by L1, L2, L3. Okay, so like this is L1. L1 equal to A1 by total area. This is L2, A2 by total area. This is L3, A3 by total area. Then what will be shape function? Shape function N1 equal to L1 2L1 minus 1. This is for shape function 1. Then shape function for 2, N2 equal to L2 2L2 minus 1. Similarly, N3, N4, N5, N6. So these are the formula or no need to remember. If you are solving any problem, they will provide you. For example, now I want to find L1. What is our L1? L1 equal to this one. This is L1, L2 we have to remember. And what is N1? Area opposite to node 1. What is A2? Sorry. What is A1? Area opposite to node 1. What is A2? Area opposite to node 2 and area opposite to node 3. This is our A3. And what is AT? AT is our total area. And we got our total area is 4 for this special problem. It can vary for different to different, vary to problem to problem. Okay. What is the A11? So now I'm going to put, so be seen here, what is our A1? This is our A1, A2, A3. So I kept here A1 equal to 1 by 2 minus 4x minus 2y plus 8. So this is our A1 and this is our 4 is our total area. So after putting all these value, we will get L1 equal to this much. Okay. Similarly, L2, L3. So we got L2, L3. Then what will be our shape function N1? Then our N1 will be L1 to L1 minus 1. So this will be our N1. What will be N2? This will be our N2. L2 to L2 minus 1. This will be our N6. Similarly, we can find N3, N4, N5. I think it is correct. Are you getting that correct?
Actually, this basic I have not covered, sir. That is why I'm not.
Okay, so like next class you can discuss again also. But I'm just giving you one brief introduction about how we can find shape function and all these things.
Okay, sir. Fine.
So like in like here I told you now. So first we have, for example, we have to find. For example, I want to find that stress. First we have to find shape function, then displacement, then strain, then stress, then force. So first our step is to find shape function. So in FEM, every time we will talk about what is the shape function, how to find shape function. Then simply these are simply mathematical expression you can easily put in, you can get all these values. But main requirement, we have to find that shape function. Okay, so for this problem, we are having 6 node, and we already find that six shape function. Okay, so like in other case, we will have some like 8 node, maybe it can be 8 node also here and 1 node here. We have to follow same procedure, and we can find that shape function for 8 node also. It can be 3 node also, 1, 2, 3. Okay. Then yeah. Now till now we study that triangle element only. Now we are going to learn about little bit about rectangular element. Like we are calling bilinear also. Bilinear also in 2 directions, x and y. Okay. So this is our 4 node rectangular element. It is having 4 node. Okay, and each node having 2 degrees of freedom, x, y, x, y, x, y, x, y. So this is our one of the element E, and this is node 1, node 2, node 3, node 4. Node 1 having coordinate x1 by 1. This is having x2 by 3, x3. Similarly, all nodes having coordinate. Now we have to find the shape function. See, we are having 4 nodes, so we will have definitely 4 shape function. We cannot have 3 or 5. Number of shape function equal to number of nodes. Okay, so we will have 4 shape function n1, n2, n3, n4. Okay, how we can find that shape function n1, n2, n3? See, at node 1, we are seeing this is connected with node 2. Also, it is connected with node 4. So this node 1 will have X effect, also Y effect, because it will have both effect. Because it will not move in it will move in this direction like this, in like resultant of this direction. Okay, so like how we can find that shape function for this bilinear element. So first I will tell you how to find shape function for in one direction. So for example, I will add one page here. Okay, so like this is our I will say write in other. This is our one of the element. So element length LE, x1, x2. This is length LE, and this is the node 1. This is node 2. So we are having 2 node, and it is having 2 x1, x2. So it is having two nodes. So, and it is moving in x direction only. I'm not, this is totally horizontal. It is moving in one direction only. So you heard, I think you heard name this one like Lagrangian. Lagrangian somewhere. So how to, by using Lagrangian method, how to find shape function? I think you know how to find, like I want to find n1. So n1 equal to x minus x2 equal to x2 minus x1. Yes. Similarly, what will be n2? n2 will be x minus x1, then x x1 or x1 minus x2. For example, I'm saying this is truss. This is truss. It is having length L. This is x1 equal to 0, node 1, x2 equal to x2 equal to or L. This is moving in one because this is truss, so moving in one direction. So I think you remember what will be shape function. So we know that n1 equal to that what we can write x by L minus 1, then n2 will be I think x by L, yeah, like this. So these are, I think, by these equation you can get by different means. So what I'm trying to say, so by using that Lagrangian method, what we can get, if I will put value here, so for example, I'm saying x1 equal to 0, so n1 equal to g, that x minus L by, this is length, this will become length L. So n1 will become x by L minus 1. And what will be n2? So I'm going to put value of x1 and x2. So n2 will be x minus 0 by L, then n2 will be x by L. I think this one you remember, these shape functions. So by using that Lagrangian method, we can find that shape function n1 and n2 easily. Yes. Now I'm saying that this is only in one direction. For example, we are having 2D element. This is 2D element, and so this is node 1, node 2, node 3, and node 4. So this is moving in two directions. So like this will have x and y, x and y, x and y, x and y. So for example, I'm going to find that shape function for n1. So I will write, so n1, it will have effect of x and y. So n1 x comma y equal to, then n1 in x direction, and then n1 in y direction. So see how we will write here n1. So like how we will write here. So this is having length L. This is having length this is having like coordinate x1, x2. So how I write n1 equal to x minus x2 by x2 minus x1. So for example, if I will write here similar, by using similar concept, what will be our n1 here? So this n1 will be, we are talking about this horizontal direction. It will be, so I will say this is x1 and y1. This is x2 and y2. Similarly, this is x3. These are coordinate x3 and y3 and x4 and. So can you give me an answer? Are you getting something what I'm trying to say? Anyone?
Yes, sir.
Okay. So like then what is n1? N1 means like x minus x2 by x2 minus x1. This will be your n1. What will be n1 in y direction? This will be, so we are talking about on this direction, it will be y minus y4 divided by y4 minus y1. So like this we can write for this this element. This will be your n1 x comma y. Similarly, what I am trying to say here, here. See, so like for this is x1 minus x1. This I missed that one. I wrote another way, but anyway it will become positive. So like for this shape, this node, for this node n1, this node n1. So how what will be shape function? So small n. So like shape function in x direction into shape function in y direction. We are not calling into, just like I'm saying here. So like n1 in x, n1 in y. So what is n1 in x? So x minus x2, then x1 minus x2. This is the length of this element. Similarly in y direction, y minus y4. Y minus y4, because this is our y4 coordinate. Then again this is length of y1 minus y4. So this will be our n1. Then what about n3? I want to write for this. So then n3, so this will be our x, this will be our y. So x minus x4, so this is our x, this is our n in x direction. So x minus x4, then this is a length, so x3 minus x4, and this is again y direction, y minus y2, then y3 minus y2. Similarly, y2, y3, and y4. We can get all these shape function. Yes, we can get easily, not a issue. One question, like this is one small problem, like we are having one 4 node element. So node 1 having origin 0 0, node 2 3 comma 0, node 3 3 comma 2, node 4 0 comma 2. We have to find n1, n2, n4. So what will be n4? N4 we know n4 will be, what will be n4? Like n4 equal to where n4, this is our n4. So see, this is in x, this is in y. So first I will write x. So x minus x3, then x3 minus x4. This will be our x. Then what will be y? Y will be, this is our y. So y minus y1, then y4 minus y1. But after putting value, you will get this n4. Similarly, you can find n1, n2, n3, whatever you want, you can find by simply putting that expression. This is not big task, just we have to do only. Similarly, like for example, we are having 6 node, 1, 2, 3, 4, 5, 6. This is for 6 node rectangular element. Then I want to find n1. So this will be our n1 x small n1, then n2. Sorry. So for this, we will have 2 node effect, like this element and like I will say this element effect, this element effect. So this will be for, the total will be in x direction, but here we are having only one element, so this will be for one element. This is not a big task. So I think for today that will be enough. We don't or we have time. Still we have little time. Any doubt till now?
Okay, you can continue, sir.
We can continue now.
Yes, yes.
So what we can do? This is solution. Now we will solve some one problem here. This problem we were going to solve. First we will write this. First we will read this problem. Suppose 2D isotropic element, elastic body as shown in figure 1. So we have figure 1. Okay, this is our figure 1. In figure 1, we are having two triangular elements. This is element 1 and this is element 2. Okay, fine. They given that we are having total 1, 2, 3, 4, total 4 node, and they provided that for node 1 we are having 0 0 coordinate, node 2, node 3, node 4. Node 1 having u1, u2, u3, u4, u5. These are displacement x and y. Okay. some information given, but now we know that we are having two triangular element. Fine. Okay, the temperature of, okay, suddenly the temperature of the body reach 150 degrees Celsius. Okay, so you are from mechanical or civil background, like both of you?
Mechanical.
Okay, and Nadlan, you are also from mechanical?
Yes, sir. Yes, sir.
Okay, then fine. So like you know that all this is thermodynamics, like not heat and mass transfer. Suddenly the temperature of the body reach, okay, this much. The coefficient, okay, this much giving, okay, this much, all the their parameter, okay. Now the body is discretized by with two CST element, okay, in figure. For a what is CST? CST means constant strain triangle. अरे कहाँ गया? Triangle. So this is CST element. So like we are calling short form CST. Element shown in figure, okay, fine. For a CST element, psi1, psi2, psi3 are shape function. We are calling n1, here n1, n2, n3. These are some different terminology, so no need to worry about. Okay, because we are having 3 node for one element, that will be 3 shape functions. So these are the shape function. And given that, see, in this problem, they given that this n1 or psi1 will be this much. Oh, this is they given that in general form. We have to, like, for example, I'm going to find that psi1. What will be psi1 from here? From here, what will be psi1? Or I will say equal to n1. What will be our n1? N1 will be 1 by 2e. 2e means total area of that element. Then what is alpha? Alpha we are calling like A1 in our terminology. And what is beta? Beta we are calling B1 X. What is gamma? We are calling C1 by. Okay. Then how to find A1 beta, like how to find alpha, beta 1, gamma 1? This is our, they given that. So what will be A1? Like A1 will be, I will write here. A1 will be A1 equal to, according to A1, like equal A1, so it will be x3 by 2, then by 3 x2. Then what will be B1? B1 equal to simply, and then B2 minus B3. What will be C1? C2 equal to, C1 equal to that C2, then C x2 minus x3. So this will be our value. That okay. They also mentioned that I, J, K are the permutation of natural order. Okay. They mentioned that A is the area of CST element. That element total area. Okay. Now we have to find that answer of linked 2 to 6 question, and coordinates are given in mm. I think question is clear for you, right? Yes. This is clear. Now in FEM, I also told you, element stiffness matrix will be like this. This is given that. Okay. Consider order of node numbering 1 to 4. Like 1 to 4. So like 1 to 4. Okay, so like if I will like they are saying consider in anti-clockwise direction. So in this way it will be 2, 3, 4 like this. 2, 3, 4. It will be 1, 2, 4. That is okay. What we have to find? What is the strain element of this? What is the strain displacement? This matrix we have to find for element 1. For this element, we have to find that this matrix, where this is here. For this element, we have to find this matrix we have to find for element 1. Okay. Anyone want to try, or should I start solving? Hello.
Yes, sir.
You want to try this problem?
Sir, I have another doubt in assignment number 8. Can you solve that?
Assignment 8.
Yes.
Okay. Okay, so let me open assignment. I didn't see an assignment. Okay, let me open where is assignment 8. If I know, I definitely I will try to solve. If not, then again next class I will solve. Okay. So just
Okay. Okay.
I'm not that much expert. Okay, we assignment 8. Assignment 8. So like you are saying that our class assignment, or you are saying that your assignment?
Sir, yeah, NPTEL assignment. Class
Okay,
assignment.
then so give me, tell me that question. Or you want to share your screen?
Question number 6, sir.
I don't have that assignment. Can you show your can you share your screen?
Okay, sir. Sir, please wait for 2 minutes. Sir, my screen visible? Hello?
Yes,
Hello?
you see me visible.
Okay, okay, sir. This one, sir. Sir, have you got it?
Can you hear me? Because
Yes, sir. Sir, have you got it?
क्या हो गया? Can you hear me now? Because
Yes, sir. I can hear you.
oh, I got disconnected from so yes. So what the? Can you tell me what the issue?
Sir, I couldn't solve this question.
See, what the boundary? Can you tell me what the boundary condition?
Okay, okay, sir. I'm scrolling. Sir, this one the questions. This is a linked question.
So consider two-dimensional element subject to reflex via position. Okay, this much boundary condition of domain shown in the figure. The domain satisfies two number single element and degree of freedom so as shown in. solve the domain find note the answer given.
The question number 5 is okay, but question number.
Okay, then go. Okay. But let me take one screenshot for this one.
Okay.
Yes, now go down.
Okay, sure.
See, this is okay. You got this answer.
Yeah. The question number 5 is okay, but question number 6.
So, like only issue, like you are not understanding how to put that boundary condition. That's it, na?
Yes, sir. I from the lectures which I have learned, I try to do this, but my answer is different than the options that are given in this question.
One thing, like you know all these stiffness coefficient KU, KQ, you got all these.
Yeah, sir.
And TU, TK you also got, right?
Yeah,
T2, T3.
yeah.
This is T2, T3.
Yes, sir.
Now, like, let me know what is F and see. Only issue what is F and Q. This is the main issue, right?
Yes, sir.
So 1 minute.
Actually, when I am solving this question, I got the matrix like. Thank you, sir.
So this is our flux per unit area, and this is flux per unit length. So this is our internal force, this is our external. So because are you able to hear me?
Sir.
So see, like, can you go up that main problem?
Okay, sir.
See, like, what is Q? Qn is the, like, if I will say like in force or in like heat and mass transfer terminology, this is flux, like, or heat per unit length, right? This is Qn, correct?
Yes,
Qn,
sir.
flux per unit length, and what is F? Like, I will try to explain another way. Like, we are having this one body, and this is generating heat, or like this is having.
Sir, your screen is not visible. Please share your screen so that I can.
Okay, I will just speak. Can you hear? You cannot see my face also. Okay, but just see, like we are having internal force or external force, right?
Yes.
So
Sir.
every time when we are talking about internal force, like we are talking about per unit volume or per unit area, internal force.
Yes, sir.
And external force, no, mostly we are talking about per unit length. So like this
Yes,
small Qn is the like flux or heat per unit length. So we will call it as a external force, and this F which is the internal force, like strain or strain. So we are calling per unit area. So when you are putting that value, you have to multiply by length or area, correct?
Yes, sir.
You are doing that one.
Actually, I am solving the question in the same manner as it was solved in the lecture by the professor. But after solving this question.
1 minute, I will give you correct way. Elemental force. One more thing that because are you transferring that load to node, or you are just are you transferring node load body, like full body to node at each node?
Yes, sir.
By using shape function. Did you
Sir,
get
I
what
just solve it like the professor was solving.
Can you
I
show
have,
me that, professor, that derivation? By the way,
uh,
you have PDF or some notes?
so yeah, I have solved on it in my paper. And
Okay, 1 minute.
what I did, I calculated the stiffness matrix at node one
Hmm.
element for element one and for element two, and then I merged one and two.
Hmm.
After that, when I
See, let
calculated,
me share my screen, okay?
okay,
1 minute. Then you will get some idea. I think you are doing correct. Only one thing I observe that I think you are some missing that is shape function somewhere. Can you step your screen?
okay, sir.
Yes, see. I think now from there you will get idea. So from here you will solve. Like we are having one body. So this is like 3D body. I will say this is 3D body. So like we are having, see, this is, I will say this is body force per unit volume. Okay, this is our body force, or I will say external force, or this is our internal. This is external force per unit area. So if I want to transfer to any node, what we have to do? We have to multiply by this shape function force into volume. Similarly, plus shape function force into volume. So according to your problem, where is your screenshot? I forgot. So like according to your problem, I had like they are having this much like this. So you are having some like F and Q. So this is like force like flux per unit length for element 1 and element 2. We are having 2 elements, right?
Yes, sir.
Okay. So like I will say this is node 1, node 2, node 3 and node 4. Just see here. So I think next you will get idea. So node 1, node 2, node 3, node 4. First, what you did, you calculated element stiffness for node 1, element stiffness for node 2. You got this one, right?
Yes, sir.
Then you added, you got one global matrix, one K1 plus K2, you got one matrix.
Yes, sir.
Correct. Similarly, see, on this surface, they are putting this flux per unit length. So I will say this is like this force, because we are talking about only 2D. So this will be like for here, for this side, or for this element, what will be like, this will be N transpose into Q into our like length. This I will say this is like flux 1 plus this one also. What we have to do? So like N transpose F into area of triangle for this triangle area 1. So this will be for this one Q1. Similarly for this element Q2, but we don't have anything here. Here also we don't have anything. So this will be only for N transpose F into A2. Did you get something what I'm trying to say?
Yes, sir.
So you are doing also same thing.
No, sir, I am not doing this thing.
So did you use that same function? Look, actually, why we are doing that? Why we are multiplying for same function? Because this is a distributed. I will talk about load, because this is distributed load, and we have to transform, or like I will say this is distributed heat, and we have to transfer to each node
Yes, sir.
by using shape function.
Shape function.
Similarly, this way also. just try to do this way, or next class.
Okay, sir. I will try it this way.
Or next class, show me your notes, some like what you written. Then I will be more. It will be easy for more to understand.
Okay, sir.
Okay, na?
Okay. Thank you, sir.
So, any other question? Any other question? Because
No, sir.
then what we can bind up for today. This is enough for today, I think. Oh, this problem